Hello everyone, in this backup video for lab number 3 we are going to start writing SQL queries, and to do that we prepared an example database file. In the handout you can download this ODB file if you want to follow along, and this is a very basic one with 3 tables. If you open it, under tables we have 3 different tables of company, partner of, and user. Basically we are storing a bunch of users in this database. For each user we have the name, surname, and a credit number. This can be thought as the money that they have. We also have a status, so this is something like a partnership status. We also have the date of birth, it's a data type, and we have the city. So the primary key of this table is ID, and none of these other attributes is required. So for city we have sometimes empty data. Additionally, credit is a number, date of birth is, as I said, or maybe it is a better idea to just open it in the edit view to show which attribute is using which data type. The credit is a number, the ID is a number, and the other ones are text except for the date of birth. In the company table we store the company name, and there is a monthly payment for each of these companies, and we have the relation partner of in between a company and a user. So you can think of it like this. We have the users that are partners of some companies, and for those companies, if you are a partner, they make a monthly payment to you. So this is like the idea of this database. And in the partner of, we just keep foreign keys. So user ID is a foreign key that references the table user, and company ID is a foreign key. This time it references the company, the primary key of the company. And to do that, if I open it in the edit view, you will see that they have the matching data types. So in this partner of table we get the user ID and the company ID, and this is a many-to-many relationship, meaning that we can have duplicate user IDs and we can have duplicate company IDs. In other words, for a user there could be multiple companies, and for a company there could be multiple users that are partners of this company. And just one thing to check is under tools and relationships. So this is how the relationship is defined. Remember, when we were creating these relationships, we always start from dragging from the primary key of the parent into the foreign key of the child. So in this case, from user's ID to user ID of partner of table, and from the CID of company into the company ID of partner of. And if you double click on these links, you will see that the parent is appearing on the right side, and we also enabled delete and update cascade options. So other than that, this should be simple. We did not make any changes into our database. So remember, in the last lab we were creating queries, but we were using the create query in design view option. So if you click on this, you have the option to include some tables, maybe the user table. I will make it larger to see it better. So we were able to project some of these attributes. For example, I can get the username, and also let's say I first get the ID, and also I couldn't. Okay, I get the ID from the user, and then I get the name from the user, for example. And remember, we can have some criterion. So for example, for the status of a user, I might say that, okay, this should be equal to full. So basically, if you check the user table, the status can be 3 different things. So it can get 3 different values. We can also type any random data. It's not prevented, so it's not enforced. But how we use this database is kind of in a systematic way, that we decided that status can be 3 different things, either full, half, or quarter. So I'm with this query looking for the ones that have status as full, and let's also uncheck the visible option, because if I include the visible and run this query, I will see that okay, all of these users, they have the status as full, and since I already know that this query will bring me such records, I don't need to enable the visible option. So this is showing me the users with status full. And we were able to save these queries. So I made this in the design view. So for that, let's say list full, and this was made in design view. Then I can close this query, and remember, under queries, all our saved selection queries are listed. And if I double click, I can show the results of this query. With LibreOffice Base, we can only save the select queries, so the queries that start with select. We will cover this in more detail, but just remember that. So if I right click on this query name and click on edit in SQL view this time, I will see that this query has an SQL form as well. So I designed it using the design view, but in the backend, it automatically generated this SQL query. And this is actually, if we wanted to write such query using SQL directly, this is what we would do. So I can also create a new query choosing the create query in SQL view option. So if I click on this, I have the option to write my query directly using SQL. And with SQL, you saw in the lectures, I guess, and we have the following form. So we select some attributes from some tables, and this is like the most basic form of an SQL query. We might say, okay, I will select from the user table, but in LibreOffice Base, we should be careful about one thing. So when you are writing the SQL queries directly, if you are typing it, for the table and attribute names, you need to use the double quotation symbol. So to say that user is a table, I need to include the double quotation marks. And also for attributes, for example, if I would like to project a ID attribute from this user table, I need to include these quotation marks. And you will see that it makes them an orange color. And in here, let me quickly check if I am able to make this font larger, because on small screens it might be harder to see. Okay, I guess this would be better. So in such form of queries, so this is the most basic thing that we have. And with SQL, although in most of the applications you might be okay without the semicolon at the end of the query, but just for the sake of like using the standard way of writing it, I will also be including this semicolon at the end of each query. So this is the most basic form that we have. And for these keywords like select and from, it's just a convention that we use uppercase letters. It is for us to be see easier. And if you write everything on just one line, that's also okay. But most of the time, to be able to see it better, we include each of these keywords on new lines. So this is one basic query. I can click on this run query button or use the hotkey F5 to run the query, and I will see that all my users are listed and I project their IDs. If I would like to also include their names, so in between double quotations, I can write name here. And if I run it now, I will also see the names of these users. So right now I'm involved with just one table, but in future we can have multiple tables, and when we have multiple tables, there could be some attributes with the same name. So for example, in this database there is none, but in some database there could be an attribute called ID in multiple tables, and in such cases you need to say that which table this ID comes from, and to show that we include the table name followed by a dot and then the attribute name. So this is the same thing. If I run it, I will see the same results, but what's different is that we explicitly shows or say that ID is coming from the table user. And in here, be careful, this is not like that. So if you include the dots in between the quotation marks, this will give you an error. It will say that I cannot find this. This is the user ID. So it says that it cannot find it. It's not a table, it's not an attribute, because what we are actually looking for is inside this user table the ID attributes. So if you just have one ID attribute, then you don't need to specify which table they are coming from, basically. Also, some note to say that this double quotation marks, and there will be a couple of more things, these are required for LibreOffice base only. So in some other applications as well it can be required, but there are some applications that use this form without the double quotations, and in the course, in the exams and quizzes, you can just go without any double quotations. So for exams, just do it as you see in the lecture. But for using it in LibreOffice base, we need to include these double quotations. So this is some rule that base is following. So other than that, we might have some where conditions. So I can say where and then include some condition for some of our attributes, and remember with the other one we were saying that okay, status should be equal to full. So with this one thing to notice is that for any text in string we need to use the single quotations. So if I run this now, I will see that now I have less users. These are the ones that that fulfill this condition. If I omit the single quotations, then it's a syntax error, because full is not a keyword. If I use the double quotation, I will see that okay, now it thinks that full is a table or an attribute, and it cannot find it because it's not an attribute and it's not a table. It's going to be used as a text value, so therefore I need to include this single quotations. Again, these single quotations are something special for LibreOffice base. And remember, I already said that this can be in just one line, it will still run. I could have some spaces in between the items, meaning that keywords, the table names or attributes, or some operators as well, it will still run. So how you write is just for our sake, to be able to see it better. So this is the same query. I will now save it. Let's name it as find full, and this time we made it using directly SQL. If I save it and close it, these are equivalent, and I can also right click on the one that I made with SQL. So this one was made with SQL directly. I can open it in the SQL view, and I can also right click and click on edit to see it in the design view. So this is like in two ways. If you write the SQL code, it also generates the design view as well. So this was something that we would do with the design view. Then what's the advantage of writing directly SQL? So with simple ones, there is not really an advantage, but with more complex queries, with some of them, it's either hard or not possible to do it in the design view. And additionally, with this design view, we are only able to create selection. We are only writing select queries, but we also have delete, update, insert, and create queries. So with these ones, we need to write the code directly using SQL. But for simple ones, you can like create the query in SQL view. You can create the query in design view, and if you need the SQL code, you can just right click and get the SQL code from this SQL view. So this is one way of writing SQL in LibreOffice Base. But with this, we can only write select queries. So if I try to write an update or an insert query with this view, it will not run. So this is only for selection. We have a second option. So if you go through if you go through tools and then SQL, we have this execute SQL statement window. And in this window, we can write and run any query. So using this, I can run any query. So meaning that I can also run the selection queries. So I can write select ID. This is the attribute, and also the name from the user table. And we had a condition saying that where status is equal to, in single quotations, this time full. So I can execute such queries. So it says that command successfully executed. But since this was a selection query, it returns the output. For some queries, I don't receive the output. For some queries, it will operate on the database, on the tables. But with selection queries, I should enable this option saying that show output of select statements. Now if I execute this query, I will see my results listed in here. So it says that command successfully executed, and while this window is open, I can go back to any of my previous statements. And with this one, you get the output is not that nice looking, but the advantage is that we can run insertion, deletion, and update queries in this view as well. So therefore, now I will be using this view, but since the text is not that large in this view, I will use a separate notepad page to write my query, and I will copy it and paste it here to execute it. You don't need to do it that way. So I'm just doing it to be able to see the text in small screens better. So what I will have is that, so instead of writing it directly here, I will write it here. It uses some different coloring, but that's understandable. So now let's write some queries. So this was the most basic one that we could have. Let's also use some number for comparison. And for the selection queries, remember, I can also create these queries in SQL view and save them. But for some of the insertion and deletion ones, I cannot do that. So therefore, I'm using this execute SQL statement window. But one thing to be careful about is when we close this window, your queries are not saved. So under tools and SQL, if you try to check the previous comments, it only keeps them while this window is opened. So let's say if I'm writing and testing a bunch of queries, it's a good idea to have some separate text file to store my SQL queries in there. In future, when we start using the interface, when we start putting some buttons, etc., we are going to use macros, and with macros, you can include your queries inside those macros. So this is some topic for the future, but for now, since we are just testing these SQL queries, I will be using this window. And so if you need to keep your queries, just make sure that you keep them in some separate text file. Otherwise, you cannot store them in this ODB file if you don't use this create query in SQL view option, and that's only possible for selection. So let's suppose that I would like to find the users that have at least 400 credits. So one of my columns or attributes was named as credit. Maybe this is actually, so I choose the SQL syntax here for the coloring, but maybe it's not that good for this one. I'm not sure. Let's try to, the color is like a little, maybe it could be hard to see for some screens, and maybe this one, not really. Okay, sorry for what I'm doing here now. I should have done it beforehand, and maybe just not use anything at all. And is it an option still? Yeah, this kind of looks good, good enough. I will just check one thing, whether we can make the font in execute window big or not, but I guess it's not an easy to reach option, or maybe it's not available at all. Okay, this is something else as well. Okay, no problem. I guess we can see it, hopefully. Yeah, the color is okay. I know that I'm doing something not that good. So we would like to, yeah, that's okay, I'll get. So we would like to find the users with credit at, or let's say it like this, we would like to find the users with at least 400 credits. So remember that with any of the attributes we can use less than, greater than symbols, we can use this equal symbols, and if you put these symbols together, it means that not equal to, so it will find the ones that are not matching. And we can also say less than or equal to or greater than equal to. In this case, since we say at least 400 credits, it's better to use greater than equal to. So this is going to be my query, and as I said, I will copy and paste it here and execute it. And remember, this is a selection query. I need to click or enable the show output option, and I will see the users along with their IDs as my output. And if I were to copy this and create query and SQL view, if I paste it here, I can save this query. Let's name it query 1, and I can run it and see the results in a better view. But since we are just testing now, we will continue using the under tools SQL option. We are going to use the execute SQL statement window. So let's say that for this one, we would like to find name and date of birth of the users that are born between some two dates. So instead of showing the ID, now I'm interested in the name and also the date of birth. And remember, these attribute names should match exactly. So be careful about capital or small letters. Be careful about how you type them. Be careful about any spacing, and with table and attribute names, it is better to leave no empty spaces. We are still looking at the user table only, but now we would like to have a condition, this time for date of birth. So this is going to be my attribute, and for this date of birth, let's say that I'm interested in the ones that are born between 1990 and 2000. Since this is some data type, I need to write its value in some predefined form. So for the date, similar to text, I need to use the single quotation marks. And for the year, so this is going to be following such a format: year, month, and day. But instead of these, I should write the exact number. So this is going to be the value. So I want the date of birth to be larger than 1990, and I also need to include the month and day. So let's make it the start of the year. And then for the other part, I want this to be smaller than some value. So I want date of birth, so I will copy it, to be less than or equal to, or you might also get rid of this equal part as well. It's according to how you would like to specify the years. So I will make the year 2000 this time. So for date of birth, this is my first condition, and I also have some other condition. So, and these two conditions should be true at the same time because of this AND operation. So with the AND operation, this condition and the other condition should be true at the same time. And since we are defining our range, so the date of birth should be larger than 1990 and it should be less than 2000, it can be satisfied. So if you write some let's say some non-overlapping things, so for example, if I were to write it should be less than 1990 and at the same time it should be higher than 2000, this cannot be true and it will return nothing. But it will not give you error, it will just return nothing. So be careful about how you specify your conditions, and in the exam as well. So these small symbols could make something correct or incorrect. So right now I have my query. Let's get it to the execute SQL statement window, and I will execute this query. Remember to enable the show output option. I see the usernames, and if I check the date of birth, these are in between 1990 and 2000. So since we sometimes have like between or let me say it like that. So having an attribute between two different values is a common thing. So there is a special keyword for that. So instead of writing it like this, we can also write date of birth is between. So this is our keyword. It is going to be between this one and this one. So this time I do not use the less than or greater than operations. Instead, what I do is, so where date of birth, this is my between condition, it is going to be between two things. It is just for the date of birth. Maybe this is a better way to show it. This is going to work the same, but maybe with some less wording, so it projects the same data. One other thing that we might use is a set of values. So let's say that we would like to find the name, surname, and city of some users, and we have a condition for that users, and they have to live in either Ankara, Istanbul, or Izmir, let's say. So I would like to find the name, surname, and also the city of some users, and I have a condition saying that their city should be equal to, so I will first write it with the long form. It should be equal to Ankara, or it should be Istanbul, or it should be Izmir. This is some way of writing it. But if the list goes on, if I'm giving 10 different cities, then this becomes not that happy, right? So instead what we can do is we can use these parentheses, and in between those parentheses I give the text, different text. So each of these city names have the single quotations, so that's important. We need to include these single quotations, otherwise we have a problem. But they are separated with commas, and they are in between parentheses. But this time, instead of saying equals to, because city cannot be equal to all of them, the keyword is going to be in. So I'm saying that this attribute city should be in this set of values, If it is equal to just one of them, it's enough for this criterion to be satisfied. So it cannot be equal to more than one thing. Actually, it is going to be either equal to one of them, or it's not going to be in this set of values. So if I come back here and execute this query, now I will see that these users are living in these cities, and I also project the names of those cities. So one thing that we can use is this in keyword followed by the parentheses. Let's, for this query, say that we would like to find the name and surname of the users without a city record. So remember, only the primary key is required in this database. We did not make any of the other columns required. So for the city, some of the users left the city field empty. So some of them does not have any city record. And to see these users, we would like to say that, okay, the city is null. So this attribute city should be null for the users that I'm listing. So if I paste it here and execute it, and I will see that, so these three users, I can also check them from the tables and user table. If you check these users, they do not have any city information, therefore they are returned in this query. I can also write is not null. This time it will be for the reverse. So now I'm interested in the ones that give the city information, and such users are listed. So sometimes we might need to find the ones that are null or that are not null. So that's useful for such situations. Also remember that we were able to use regular expressions, meaning that for our string we were able to use the star symbol or the question mark symbol to be replaced by, for star symbol it can be replaced by any number of any characters, and for question mark it can be replaced by any character. This regular expressions can be used to create very complex things, but in our case we most of the time use it for searching something starting with a letter, or maybe we are searching a letter inside inside any position. So for this one, let's say we would like to find the name, surname and credit of the users, and for these users we want the name to start with the letter W, or we want the surname to include the letter O. So we have two different conditions. It can be either one of them. Either the name starts with W or the surname includes the letter O. So we are projecting name, surname and credit this time. And we are still involved in the user table. It's the same table. And our condition is this time for name. We want the name to be like. Remember, when you are using regular expressions, the keyword is like. So instead of writing equals to, we have to write like. It's going to use the regular expressions. And then I need to give the text, the string. So I can write the name directly here. So this is going to be a valid query. it will only return for Ali, and Ali is not available in this table now. But I can include the regular expressions. I can write W followed by a star symbol, meaning that the name should start with the letter W, and after that there could be nothing, there could be multiple characters. For all of them, I replace this with the star symbol, and if the name is starting with W, that's okay for us. And I have an OR condition. So either it starts with either the name starts with W, or the surname includes the letter O. And in the table, if you go to the user table and check it in edit view, you will see that we are using for both name and surname the text that is not the text that is case sensitive. So it's not the ignore case version. So the upper or lower case letters are important. They are different. So therefore I need to be careful. So I said that name is like W star. I use the capital letter W because I know that in the name attribute I always start with an uppercase letter. If this is not some rule of my database, so rule meaning that while I'm using this database I'm following this rule, there is no enforcement. But if this is some rule that I'm following, this would be okay. But in other case we can also include this one. I can say okay, name is like W star, and not and for this one, or name is like W, the small W star. So this can be one of my conditions. But now since we always start with capital letter W, let's just leave it like that. The other condition was saying that surname includes the letter O. For this one, this time we need to include the both versions. So I will say there could be any number of any characters at the beginning, followed by a small O, and there could be any number of any characters followed. Or it could be using the capital letter O. If it's at the beginning, I need to also include it for the capital letter O. So with this query, I have 3 different conditions, and for these 3 conditions I'm using the logical operation OR. And if one of them is correct, I can show this user in my results. So I will copy it and paste it here and execute it, and you will see that so William has the name starting with W, but for Brandon is here because there is a letter O in the surname. For Wayne as well, for Martha as well, for example. Actually we just have William that satisfies the name starting with W, and also the Wayne. But for Wayne there is also the letter O in the surname. So Wayne is here because of 2 different reasons. So let's continue. Let's say that sometimes we are also interested in unique values. So I might be writing the cities from the user table with such query. Maybe I'm interested in finding which cities my users are living. This is my query. If I paste it and run it, I will see the ones with matching cities multiple times. So this is projecting the user table, it is only projecting the city names, but for different users, if they are living in the same city, I see them multiple times. So to avoid that, we can include the keyword distinct. This will show only the distincts this, so it will make the projection and then it will get rid of the duplicate values. So if I execute such query now I will see that each record is shown only once, and it also sorts them accordingly. So last time without the distinct, it is showing per user, so this is the order of the users. First user has no city, second user is from Izmir, etc. But if I include the keyword distinct, so I can choose from the previous commands, I can just choose this one to carry it here and execute it. The results are sorted, so null value is on top. There were 3 null values, but it's only shown once. And for the rest of the city names, they are only shown once as well. So let's say that now we would like to find the highest credits of the users. So sometimes we would like to inspect our records, and to do that we have actually some functions. These are called aggregate functions. It's something different from the aggregate relationships, but these functions can be used for columns, for specific columns, and they can find the maximum, minimum, average, or the sum of the values. And when you are using a function, something to be careful about is that you can use the function next to the select keyword. So you cannot use the function's result directly for a where condition. So the functions can appear next to our selection. So in the user table, I can say that maximum credits. So this is going to be my query. And if I carry it here and paste it and execute it, I have a problem because I forgot to include this second double quotation mark. Now if I execute it, I will see that it's showing 1050, and if you check the user table, the maximum amount of credit is 1050 by Betty. The other functions that we can use are the min. In a similar convention, we use all uppercase letters for the function names. So if I paste it, actually let's also try what happens if I include 2 queries. So it actually runs them as a whole, but shows the last one's result, so it's not giving me an error. But if I were to not include the semicolon at the end, okay, that also works. But while we're executing, just include 1 query at a time. So if I execute it, the result is 0. So if I check the user table, there is 1 user with 0 credit, and I'm showing that user. There is also the average function, AVG. If you execute it, it will show you the average of the credits. There is also a function for sum. It will show the sum of all values in this table. And one thing to be careful about is that, so there is also just one more function. Let me also show it, the count function. It counts the instances of the data. So I can include the column name next to count. So let me carry it here. I could not, okay. I can include the column name next to count. So for this query, if I execute it, it will show me the number of users counted using the column credit. And I know that for all users I have some credits, but I know for 3 users city is null. I can also count based on city, and if I do it that way, those 3 users are not counted. So the result is 17 this time. And then I also have the option to write a star symbol here. And if I'm writing the star symbol, I don't use any quotations. So this star symbol directly goes to the parentheses. This means that count the entries as a whole. So if I use it, I will see that there are 20 different users, and it will count based on the rows that are inside this user table. Otherwise, we are just looking at separate columns, so be careful about that. So remember, we were saying that, so for example, for credits, if I'm finding the maximum credit, I cannot use it for var conditions directly. So maybe let's say that I would like to find the name of the user, and let's also say name and credit of the user. That is getting the maximum of the credit. So this might seem like a good way to find the user with the maximum number of credit, but if you type it here and try to execute it, first it will return nothing. So there's a problem, right? Why there is no such user with this credit equal to maximum of the credits? The problem is that with aggregate functions, it would be better if it gave us an error. It says that not a condition. So actually it's an error, but it is kind of confusing. It says that what you wrote after var cannot be used as a condition, but it's kind of vague. It is not giving me enough information. But you should know that these functions cannot be used directly as a var condition. What I need to use in such cases are subqueries. So remember, I'm just writing some separate query. This is going to be the one that we just wrote. How to find the maximum credits? Remember, we were writing select maximum of credit, and this was coming from the user table. And if I run this little query, I know that it will give me just one result, which is the maximum of the credits. And I also know that if I were to write a direct number here, for example 0, it will also work, right? It will find me the ones with 0 credits. So it says that the name is 1, and name, actually, okay, 1 is also a name. There is also the city one, what this time it's the name of this guy with 0 credits. With subqueries, what we do is we take some correct query. So this is one query that I can just directly go and run. I include this query in between parentheses, and instead of using some value at a position, for example, instead of this 0, I will replace this 0 with my subquery. So this is my subquery. To see it better, I'm indenting. You don't need to indent anything for this query to be functioning, but just be careful about the parentheses. So I need to enclose this subquery with parentheses. That's one thing important. But if I run this now, coming to here, if I execute it, now it shows Betty, who has 1050 credits, and this is the maximum number of credits that I have, that I know. So one thing to be careful about, let's repeat that. If I'm using a function, it should be next to the select statement. Otherwise we have a problem. And let's say I would like to find the maximum credit, and then I would like to find the user who gets this number of maximum credit. In such cases, we are using these subqueries, and for subqueries, we include them in between parentheses. One thing to be careful about is that if I'm using the equal sign here for a subquery, that subquery should return exactly one result. if it is returning a set of things, then instead of the equal symbol, I should write in. If it is just returning one thing, in is still okay. If I execute this, there is no problem. And for that subquery, remember, we can have things like, okay, it will be not that meaningful, but I use it to show that we can use it. Let's select the credit from the user table, where for such users, status is equal to full. I can just write this condition to the main query without needing any subquery, but to show that what happens if you use the equals sign and if this subquery is returning more than one result. To show what happens, I'm writing that. If I execute it, it says that single value expected. So from this subquery, since I'm using the equals sign, it expects a single value. But if I replace it with the keyword in, then it will function as expected. It will list the usernames and the credit numbers for the users that are included in this subquery. And in that subquery, I'm selecting the credit of the users that have the status equal to full, which is not meaningful. That query is not very meaningful. Let's just return it to the one that we were finding the username of the user that gets the maximum number of credits, and we can change it with minimum, etc. We can also say that this credit is going to be larger than some value. If I write the credit is larger than the minimum value, I will see all my users. Or I can also write that these users should be getting more than the average credits. So that's also okay. And I can also say that these users should get less than the average credit. So in the following video, we are going to continue writing SQL queries.